Hey guys, and welcome to the 26th tutorial in our Python Language Basics course. Here we're going to go over inheritance a little bit more by taking a look at a code example. We'll start by creating a subclass of the class we already have. Remember, we have a game character class, and we're going to subclass that into a player character class. We're going to then compare it to the superclass, talk about what we can change, what we should change, and what we can leave alone. And then go over the difference in the usage between the two by creating some objects and comparing what has access to which methods and fields. So let's head on over to the code now. Alright, last time we were here, we left off in section 25. We created a couple of objects from our game character class. If you remember, our game character has a name, exposition, and health. It also has a move function, a function to help take damage, and one to check if the character is dead. So this is a fairly generic game character. Okay, we could have been a bit more specific if we wanted to. You may or may not have added extra stuff in yourself, but I didn't want to attach too much functionality to this because now we're going to get a bit more specific. Our goal here is going to be to subclass game character and create a player character class. So this player character is going to have a little bit more functionality than just a generic game character. For example, a player character will often have a few lives, or at least more than one life. That way, if you run out of health, then you have a couple of lives as backup, and you don't immediately lose the game. So that's different from most non-player characters. Most non-player characters don't have multiple lives. Once they run out of health, they are dead, and that's it, they're out of the game. But with a player character, you might have a few lives. So again, if your health bar goes to 0, you just subtract a life, you get all your health back, and you can keep playing. So that's going to be the main change that we'll make to our game character class, or rather that we'll make when we subclass game character. So we're going to need a number of lives, and we'll need to also assign a maximum hit points or max health. So we'll need two more variables. We'll actually leave move alone, and we could change it if we want to include like a Y position, but I think there's no need for that in this case. But because we're introducing the notion of lives, we're then going to have to modify our take damage and our check is dead functions as well. Okay, so that's just a quick intro into what we're going to be doing here. Right, so to actually get started here, we'll create a new cell. Zoom in just a little bit more there. All right, so we'll create a player character class. Remember, I changed the name on that game character to game character because I think we start off as player. So we'll create a class, we'll call this one player character, okay? And we want to subclass game character, so we're going to open up the brackets, and we're going to put the name of the superclass here. So in this case, game character. Now this is the way in which we subclass a class in Python. Lots of other languages will use keywords such as extends, some will have like a colon, and then the actual name, but Python uses these parentheses. So we do the superclass, and then the subclass. So at this point in time, player character has everything that game character has. Okay, that means it has a name, exposition, and health. It has this initializer. It has our move, take damage, and check as dead functions, even though we haven't even written any code for player character. Okay, and that's just because, again, it's a direct subclass. So those are automatically added in. If we want to add additional variables, we need to do so. If we want to change up the functions, we need to kind of rewrite what we have up here. In fact, Python doesn't really make use of the override keyword. So if you're coming from other languages and you are used to doing that, there's actually no need. We can provide a function with the same signature, which means the same name, same parameters, and same return values. So for here, the first thing we'll need to do is find a way to set up our maximum hit points and the number of lives as well. So for that, we're actually going to provide a different initializer. I'm just going to copy over this code to save a bit of time. Okay, so when we initialize a player character, again, we're going to need a name, exposition, and health. Those are given. We definitely need those. But we'll also need a number of lives. So we'll just say number of lives here. So that means we're using another parameter. Now, we could do things this way, but that is repeating code, and we want to try to avoid that. Also, it's not such a big deal here, but what if we're setting up like 10 or 20 different values? Then that gets really annoying having to type that code out again. So we can short form this by calling upon the superclasses constructor. So just bear with me here a second. Essentially, what we'll do is we'll say super dot init, okay? And then we're just going to pass in the name, exposition, and health. Okay. And I guess we can set up the other ones now as well. We'll just do self.maxHealth is going to be equal to health because I assume when we create the character, we're giving them maximum hit points at that time. And we'll also say self.numberoflives is equal to number of lives. Okay, cool. All right, so ignoring this for just a second here, this should be fairly straightforward. We're taking a name, expedition health, and the number of lives, and we're just setting up max health and the number of lives here. What about the name, expedition, and health, and what are we doing with this? Well, we are basically passing off the responsibility to our superclass's initializer to set these guys up. Okay, we're still taking in the values whenever we create a player character, but we're saying, okay, we're going to say to the superclass, in this case game character, we want the superclass's constructor to take care of this work for us and set these up. So when we actually go to run this and we create a player character, we'll again need to pass in these 4 values. And then it's going to get to this line of code and it's going to say, okay, what's a superclass's initializer? It's going to take in those values. We'll jump up to this. Then we'll say, okay, this is a superclass. This is the initializer. Essentially, it needs these values and it will just assign them like this. Okay, so it kind of jumps up to there, executes that code, and then jumps back into and executes this code here. So if you are going to subclass a class in Python, then you'll often use this a lot, actually. You'll use the super keyword and then whatever method you want to kind of use that's from the superclass. Okay, this is really great because it saves us, again, having to rewrite that code. We can rewrite it if we want, but then that kind of defeats the purpose of subclassing something in the first place. So again, this is just handing off the responsibility to set up these variables to the superclass because we know the initializer will set these variables up properly. If for whatever reason we wanted to execute our move function, all right, off the superclass, we can do that. We can say, I mean, we're not going to do it here, but we could say super.move, okay, and then we'd enter a by amount, okay, 5 or something like this, okay. By this logic, we're essentially saying that the superclass's move function is going to be executed whenever we do this. Obviously, we don't want that here, so we'll get rid of it. Okay, so what about the other piece of functionality? Well, we'll actually leave the move function alone. I don't really see a need to change it at this point in time. We're not too concerned about Y position or anything like that. So we'll actually leave it alone. And remember, because we're subclassing game character, we already have access to that move function, even if we don't create it again. Okay, but these 2 functions we will need to change because we have an extra thing to take into account, and that's going to be the number of lives. So again, we're not going to use the override keyword. Essentially, we're just going to provide different definitions for these functions, and that's basically the Python way of doing things. All right, so in our take damage, we're still going to start like this, subtracting that from health. We actually don't need to perform this check anymore. Rather, we need to make sure that if the health is less than or equal to 0, we're going to subtract 1 from our lives, and then we'll reset health back up to 100, or back up to whatever the max health is. So we'll say if health after taking damage is less than or equal to 0, we're actually going to say self.number of lives minus equals 1, okay? And then we're going to reset self.health back equal to self.maxHealth. Remember, we're setting up the number of lives and max health in our initializer, so these will always have appropriate values. Okay, and that's pretty much all we need to do for the take damage function. We just need to make sure that if we are kind of dead in quotations, then we want to reset the health and get rid of 1 of our lives. Then, in the check is dead, we're only going to be actually dead and out of the game if our health is below 0 and our number of lives is less than or equal to 0. So for this, we're going to say return self.health is less than 0 and self.number of lives is also less than or equal to 0. So if either one of these is greater than 0, so we have either some health or at least we have some lives, then we're not dead, okay? We're not out of the game. We just kind of, I guess, took some damage and maybe close to being out of the game, but we're still in it. Okay, so hopefully this makes sense. Essentially, this is saying we're only returning true, we're only dead if we have no lives and no health. And here, whenever we take damage, we are going to make sure that if our health is less than or equal to 0, we're resetting health and subtracting a life. Also, our initializer is taking in one extra parameter. We're passing the responsibility off to the superclass's initializer to set these variables up, and then we're explicitly setting these guys up. Okay, so that is basically our subclass in a nutshell. I don't think there should be any more implementation that we need to do here. Let's go ahead and give this a run, and we should be good to go. Now, you can add more functionality into our player character, or our game character for that matter, if you would like. However, we're trying to keep things simple. There's kind of no need to go over any more examples, so we'll keep things as they are. But we do want to see this subclass in action and compare it to our superclass. Remember that if we create a player character, it's going to have everything that's defined in the player character class and also the game character class. So that means it will have name, exposition, health. It will also have max health and number of lives. It will have that same move function from before, but it will have the new definitions of our take damage and check is dead. However, the game character is unaltered, so it will only have name, exposition, and health. It will have the original move function and the original take damage and check is dead functions as well. We're about to see that when we create some instances of these, so let's do so. We're going to create a player character. You know, let's actually just shorten this to PC. And this is going to be an instance of player character. So note how the new constructor is the recommended one. So I'll just enter a name, I'll just do my own. We'll enter an exposition, start at 0. Maybe we have 100 health, and the number of lives will start at 3. Okay. On the other hand, a game character is going to be like this. Note how, again, different constructor because we're not taking in the number of lives. Again, constructor, initializer, they are pretty much interchangeable here. And we'll do, I don't know, maybe we're fighting some kind of an animal, maybe like a wolf or something. Okay, we'll start at position 5. Maybe it will, you know what, actually, let's keep the values all the same. Okay, just for demonstration purposes, we'll say 100 and that's it. Okay, so we know that both of these player character and game character will have access to all of the same functions, but our player character has access to 2 more variables. That means that we can do this, player character.max health, okay, but we can't do game character.max health. Max health. Okay, so let's actually just try to print these both and see what happens here. So we'll do that, copy and paste. Okay, so immediately we're getting an error, and you can see that it's on this line, line 5. And that's because, again, game character doesn't have max health. It hasn't been defined in this class here. It only exists in its subclass. So again, subclass has everything a superclass has to offer, but not the other way around. Okay, cool. So what about the different methods then? Well, for the different methods, we have slightly different implementations for the take damage and check is dead. We'll see that if we run the same move function code, we'll get the same result. So we're just going to print, we'll actually do the pc.move, maybe we'll move by 2. Okay, we'll also do gc.move, again by 2. Okay, and we can go ahead and print out the expositions afterwards. So pc.expos. Okay, and we'll do the same for the game character. Okay, so both end up at 2. That makes sense. There were no modifications there. Okay, so note that we're at 100 health. So if we take more than 100 damage, then we're going to essentially either lose lives or we'll be out of the game, we'll be dead completely. So what we'll do is we'll do pc.take damage, okay, and we're going to pass in a value of 150. We'll do the same for game character. Now we're going to print out the health for our player character and our game character. So health. Remember, they should both have access to the health variable, because that was declared in game character. But now we're guessing 100 versus 0. Okay? So this might be kind of confusing because we're basically calling upon the same, well, it seems like the same function with the same values. However, because we are running take damage on player character and that has a slightly different implementation, it's going to call upon its own, which will reset the health back up to 100, but it will take down one of the lives. Okay? On the other hand, the game character's take damage function just sets the health to 0. If it's below 0, it just sets it to 0, and that's it. Okay. Then if we do print pc.checkIsDead, it's a method call, and gc.checkIsDead, we should get two different values again. So we get false for the first one and true for the second one. Again, that makes sense because our player character has multiple lives. They should still have 2 lives left because, yeah, they've taken enough damage to kill one of the lives, but we're resetting that life. Or rather, we're resetting the health and we're just subtracting one of the lives. The game character, on the other hand, doesn't have any more lives. It always starts at 0 lives, and so that is going to be true because that is dead there. Okay? So that is pretty much all I wanted to go over. I know we didn't necessarily demonstrate it here, but we can absolutely provide methods in our player character class that the game character doesn't have access to. We kind of saw that with variables because, again, game character doesn't know about these, but player character does. You can definitely add methods that the game character doesn't necessarily know about. If there was another one to, I don't know, move up or down or something, you can do that. Another example I often go over is like an inventory. A non-player character, a regular game character, might not have an inventory of items. A player character might have an inventory of items. And you can write methods that will help to kind of add or remove items from an inventory. So maybe if you want some practice, that would be a good place to start. Otherwise, we saw that we can provide stuff that a subclass can provide stuff a superclass doesn't have. It can provide completely different implementations of the same functions, so that will kind of change the functionality, and we can access a superclass's methods to kind of pass on the responsibility by using the super keyword here. So I know we covered a whole lot in a really short time, so I would recommend that you practice this concept as much as you can. I know game character is subclassing, or other player character subclassing game character. We can also have another type of character subclass player character if we want. That kind of gets the attributes of everything. Okay, so definitely play around with that. Maybe try to create some different methods in both of them. Try to implement some extra functionality. And once you think you have this concept down, you can move on to the next one, which will actually be the final lesson in our language basics. Okay, so thanks for watching. We'll see you guys in the next one.